To analyze this slope, we click the Analysis button and then move to the Analysis Properties section. I turn off the grids. Now I switch to the Analysis Properties section. By clicking the Related button, I activate the Analysis panel. The main assumption of limit equilibrium methods is that failure occurs along a predefined slip surface. Therefore, you need to define the slip surface in advance. There are two buttons on the right side to define the surface. One option allows you to define the slip surface by entering coordinates. For example, for a circular slip surface, you can enter the center coordinates and the radius. The other option is to define the slip surface interactively. To add it interactively, I click the Related button. I click the center of the circular slip surface. Then I move the cursor to define the radius on the screen. When I click again, the entered radius value is displayed here. This is a final check. If needed, you can modify the value here. I keep the value as it is and click OK to define the slip surface. Now let's review the available analysis methods. There are two methods, the Fellenius method and the Bishop method. For now, I leave the Fellenius method selected. The slip surface was defined as circular. I move to the analysis type. There are two options here, standard and optimization. In the standard option, the analysis is performed only for the defined slip surface. In the optimization option, the program generates multiple potential slip surfaces and analyzes each one. As a result, it searches for the minimum factor of safety. First, we will perform the standard analysis. I keep the standard option selected. On the right side, the XB value represents the slice width. The program divides the slip surface into slices and performs the limit equilibrium analysis using the slice method. The slice width is shown as 1 meter, and I leave it as it is. I click Run Analysis to perform the slip surface analysis. As shown, the center coordinates of the slip surface are displayed on the screen. The factor of safety is calculated as 1.08. The analysis table is displayed on the right side. You can export this table using the Export to Excel button. You can also see these tables in the analysis report. In this way, we have analyzed the slip surface and obtained a value of 1.08. If we select the Bishop method and repeat the analysis, the factor of safety will be calculated according to that method. To generate a report for the Fellenius analysis, I click the Analysis Report button. The calculations are then provided as a program output report. On the first page of the report, you can see the input data, followed by closed area data and material information. Then the analysis geometry, the formulation used, and the limit equilibrium analysis table are presented. Since we performed a standard analysis, only the defined slip surface with its radius is shown in the report. This is how we obtain the report. Now let's return to the data input section and see how we can modify the model.